This session we'll be discussing about fundamentals of operating system. So, operating system is a system software, also known as an interface, also known as resource manager, resource allocator, layered structure. So we know operating system is supposed to be installed. So what are the different kinds of operating system we have in real world, like MS-DOS, Unix operating system, Linux operating system, Windows operating system, iOS, Android, Solaris, AS by 2, different varieties of operating system. But we are all very familiar with Windows operating system and Linux operating system and iOS, especially developed for Apple platforms. So, our software is divided into two parts. One part is system software, and the other part is application software. So, application software, simple example I can give MS Office. And system softwares, whenever you talk about like operating system, like device drivers, like you want to install, for example, a printer in your system, you're supposed to have a device drivers for that. Or whenever you inject a pen drive, it has to be installed. It's a supported files. So likewise, device drivers and language compilers and language translators, all they are comes under into system softwares only. So one of the system software which you are talking, the basic is nothing but operating system. So operating system, it operates the system. Here again we have a doubt. What is the meaning of a system? So whenever you talk about the system, a system is nothing but combination of or collection of peripheral devices, collection of peripherals. What exactly they may be CPU, or they may be RAM, or they may be ROM, and there is a input device like keyboard or joystick, and output device, monitor or screen, and there are buses, and there are hard disks, whatnot. These are all collection of things. So you want to accelerate the system because system is nothing but combination of hardware peripherals. Combination of hardware peripherals. So you want to accelerate the system, then there is a requirement of what? Software. So that's why what is required. When you talk about the software, so used for acceleration, used for hardware acceleration. So you can make it run. There is a need of a software. In such software, one of the software which we have find that is nothing but operating system. What exactly the meaning of operating system? It operates. It operates a system. System is hardware peripherals. Does it need mandatory operating system to run a system? May or may not be. It's like a so for example, you are having a physical bike with you. I can ride the bike just by pushing it or by having some petrol into that, so you can ride the bike. So in this case, operating system, you can call it as that petrol. So if you pump the petrol in your bike, then you can accelerate it. It works nicely. And if you, for example, if petrol is not there, then you have to pull it. That means bike will function. but you don't have a user-friendly manner. So there is a requirement of operating system to manage the hardware peripherals easily and nicely. So it operates a system. That's why you can also call that it is a what? User friendly. It is a user friendly. So finally, we understood that operating system is a mandatory to accelerate the things, and it is a resource manager. Why it is a resource manager? Why it is an interface? Why it is a layered structure? We will see first one by one. Why it is an interface? User is a somewhere you're riding the bike with the help of petrol, but you don't know internal architecture of the bike. For example, you're driving a car. So just by having a petrol, you're able to run the car, but you don't know internal functionalities of it. That means you are a driver, you are trying to accelerate the car, which consists of pure hardware peripherals. So that's why user do not know the internal architecture of the particular device. That's why you are at the external level. User is at the external level and the system is at lower level. You can't directly access the computer resources. You can able to accelerate the things only with the help of what? Interface, with none other than operating system. So operating system is in between user and computer hardware. How come user can do this? User needs user needs an interface, user applications. User is standing or sitting exactly onto the user application interface or area or a layer where you can able to interact with this. So that's why this is a layer 1 and this is a layer 2 and the low level is a layer 3. It is providing abstraction. What is the meaning of abstraction? Hiding the details away from the user. You are not allowed to access the computer peripherals. You can able to use it with the help of what? Operating system. That's why operating system is a bridge between user and hardware, or it is an interface between user and hardware. So many kind of operating system you may hear about it. For example, Windows, which we are talking regularly. Apart from that, any interfaces which you can able to accelerate hardware, they all comes under into interfaces only. For example, I want to make use of air conditioner. There is a need of a remote. Remote is a hardware, AC is also hardware. Then how can you accelerate it? So user is trying to use the software which is there in the remote. So we are trying to make it a function. Then this is sending a signals to the software which is there in the air conditioner could understand the signals which is coming from remote. So that's why any interface, and not only Windows operating system, any interface you may talk about, they're all completely belongs to interfaces only, like washing machines, air conditions, any kind of smart appliances comes under into a small interface only. So user applications cannot access these services directly. He could able to access with the help of what? System calls. So system call serves as the program interface to the operating system services. Then operating system is an interface. So user is maybe using editors, user may be using a loaders or compilers or application utilities like MS Word, games or any kind of things. User is at external level, but hardware is at lower level. So you can able to accelerate the things. For example, I want to play the game. Just to invoke the game, then it able to control all the computer hardware. So that instructions, whatever are coming from the user, first it comes to operating system, then operating system will give in turn command to computer hardware. So user is coming with which kind of calls? User is coming with a what? Library calls. User issues library calls only, but operating system convert that library call into which calls? System calls. And with the help of system calls, you could able to contact computer hardwares. So again, let us learn. First user is coming with a library calls, and those library calls are being transformed into system calls with the help of operating system. Finally, they could able to interact with a what? Computer hardware. That's why OS is an interface between user side and hardware side. Whatever instructions are coming from user, they are transformed to understandable by computer hardware. Whatever hardware is responding, and those instructions are transformed according to users needed. So that's why they are completely bidirectional. So for example, I would like to talk about that using a small program. There is a main index print printf hello, and whenever you execute this program, so first we need to compile this program. After compilation, then we start run the program. When you run the program, then it becomes a process. Then first main got executed. It understands that main has got a block of statements like this. Then it start executing printf. What is the output of it? You're able to see output on a monitor as hello. You're going to see output hello. But user is giving which statement? Printf statement. Printf is a function. Which function? It is a library function. It is a library function. Then when it comes to operating system, then operating system converts this printf into which system call? It converts into which system call? Write system call. It converts into write system call. Then this write system call is accelerating which device? Monitor. That's how the user could able to access the computer hardware with the help of operating system using the concept of system calls. So there is other synonym for operating system. It is resource allocator. So in your computer system, you are having a limited resources that should be shared to all the rest of the programs. How? I want to watch a movie. Okay, you are sanctioned. I want to do some chat. Okay, you are sanctioned. I want to listen to songs. You can do. I want to access the printer. You can do. So whenever you are doing a multitasking concept, then there is a requirement of what? Resource sharing. So whatever the user is asking and operating system takes it and try to give, if at all memory needed and CPU needed, any files you want to open, or IO device management, or any security. So these are the resources are provided by operating system to user. This is what is the concept of what? Resource manager. And resources are comes under into two varieties, software resources and hardware resources. Software resources, whenever you talk, files. Software resources are nothing but files, monitors. And when you talk about the hardware resources, when you talk about the hardware resources, you may talk about a keyboard, you may talk about CPU, you may talk about a hardware monitor, and you may talk about other like a hard disk and so on. And software resources, you may talk about the files, and the software resources, you may talk about the semaphore, And software resources, you may talk about a monitor. It's not a hardware monitor. There is a monitor which is especially used in a process synchronization. So it is called as a operating system as a resource allocator. The types of resources I already shared. Hardware resources like I/O devices, memory, CPU, etc. And software resources are files, device drivers, semaphore, messages, and monitors, etc. The operating system is a layered organization. I already told you. Top of the layer users are there, bottom of the layer hardware is there, and middle you are being given a what? Operating system concept. So how it is done? The user interact with the help of a shell, and that shell will interact further with a what? Kernel, and that kernel further interact with a what? Hardware. So here there is a new word came, that is a shell. So shell is an interface between user and the kernel. So kernel means you may talk about the operating system is available there only. And the kernel is an interface between shell and the hardware. Again, let us come here. So when you are talking about the shell, shell is an interface between user and the kernel. Simply, I can say that command prompt or bash shell. And when you talk about the kernel, kernel is interface between interface between shell and hardware. So here exactly the hardware part available. So operating system components. So user applications, and there are different components are there with operating system. Process management, memory management, file system management, I/O management, secondary storage management, nothing but a hard disk. Memory management is nothing but RAM. Process management is nothing but CPU. Protection and security so that your files cannot be accessed by others. That's the meaning of protection and security. Networking, so communication among the system, and system calls, interfaces. Finally, they are talking with the kernel, where operating system core components are available here only. Finally, it is talking with the what? Hardware resources. Because our ultimate aim is a what? A user with the help of the components of operating system can able to interact with the what? Hardware devices. So these are all components, components of operating system. So let us see few fundamentals. Bare mission. So olden days computer systems are bare machines only. Bare machine do not have any operating system loaded, preloaded in that. A bare machine is a computer system that operates without an operating system. User interact directly with the hardware, as I told you, right? The operating system is not mandatory. I can pull the bike or I can pull the vehicle without having a petrol. Here also, I can accelerate the hardware without having the software. But if you added a petrol into that, then it accelerates like anything. So interacts directly with the hardware, and all the resource management must be handled by the application program itself, early generation computers. Then we have a concept of resident OS. Let us see, bare machine is this. This is the bare machine, and this machine do not have any operating system into that. No OS, but I could able to manage the hardware things well. And now I have the bare machine. I have the machine with me, but I am installing what? Resident OS. Then what happened? Your machine consists of a resident OS. What is a resident OS? It is not going to fetch all the operating system components. It loaded main important components, something like process management concepts and something like memory management. And whenever there is a requirement of other components, like IO components, file system, protection and security, they are all being called on demand. What is the advantage of it? So that we are not giving much time for loading of your operating system. This area I can completely give to for what? User applications. So user has got a privileged, he can able to use a more space. And resident OS initially loaded in where? Kernel. So especially resident OS remains permanently loaded in the memory while the computer is running. For example, modern operating system uses Microsoft Windows, Linux, and Mac OS. So mainly it stores important components. That's why nowadays operating systems are very easily loadable. Earlier operating systems are very heavy. When I switch on computer after half an hour, 1 hour, you are able to see the screen. But nowadays it's completely dynamic. As soon as you switch on computer, not less than 1 minute, you're able to see the screen because the concept of what? Resident OS. If I want to load the complete operating system collection of system files, it takes a lot of time. Instead of that, better you go for lightweight version. So that is the meaning of resident OS. Resident monitor. What is the meaning of resident monitor? Let me show you a figure here. So there is a memory which I am talking about, RAM, random access memory, which is having some numbers 0 and 32, 64, 96, 128, 256, and so on. It is in the form of exponential. 2 power 0, 2 power 1, 2 power 2, 2 power 3, likewise. And now some of the spaces, address spaces, I am allocated for what? It's reserved. It's reserved for what? OS only. And the rest of the spaces I can able to give to whom? User applications. User applications. Let us say a user is sending hello.c, which needs some memory like 12 bytes. Then OS is trying to check that is it 12 bytes available or not? First condition. Yes, more space available. Then it start seeing that this is the margin. This margin cannot be used by anybody else because it is a completely what? Protected. It is completely protected. This is given only for what? Kernel area. User applications cannot access kernel area. So therefore, it start identifying that I have the free space because your program is supposed to be loaded in which area? User application area only. User application area. That's why it started separated with the help of fence address. What is the fence address? Whenever CPU generated an address, if that address is greater than already provided address, that is nothing but base address, then you could able to give it, otherwise you don't give it. So then it start identifying that hello.c is not a kernel program, it is a user program, so I supposed to place it here only. Then it start placing exactly in user space. Then there is a one more program is coming by name sum of two numbers. Then it starts seeing that you can't place sum of two numbers here because it should be greater than your fence address. Fence address is nothing but, see how I protected it. It is completely 0 to 32 is only for kernel. Rest you can give it. Then it start identifying that above 32 I want to give. But already this slot is reserved. Already this slot is reserved. It is already given to hello.c. It has to be protected. Then sum.c will be given a different slot. So this is how user programs are protected themselves, and user programs are completely isolated from your kernel area. So this is how. So whenever CPU generated an address, if it is greater than is equal to your fence address, then you can able to access what? Memory. Otherwise, you can't able to access, which indicates that some of user application is trying to access kernel. Some of user application is trying to access kernel, then there may be a chance of what? System crash. That's why it won't allow you to access kernel space. This is how you can protect your operating system with the help of what? Fence address. So modes of CPU execution. Sometimes CPU is executing kernel where operating system component needed. Sometimes the operating system executes user applications, kernel applications and user applications. This is all possibility because of program status word. The program status word decides the program status words decides the CPU has to run in a kernel mode or user mode. Kernel mode is nothing but without preemption. User mode is nothing but preemption. So this is what? This is all possible using a E flag. Whenever E flag is equal to 1, it indicates that interrupts are enabled. That means you are trying to access a what? That means kernel is trying to run in which mode? User mode. Whenever it is 0, then the CPU is running in kernel mode. So modes of CPU execution. So when mode bit is equal to 1, then you are trying to access a what? The CPU is trying to execute in which mode? User mode. When mode bit is equal to 0, then CPU is executing in which mode? Kernel mode. And both supposed to what? You need to cross check every time whether am I able to protect your system or not using a fence address. What is a fence address? Even though it is a user process, a kernel process, every time it has to cross check is it greater than is equal to fence address or not. Then when it is greater, be able to access memory. Otherwise, you will be see that a concept of what? Trap. Objectives of operating system. It takes a complete control of hardware and creates a platform which is easy to user to write a different application. It's also known as a what? Command interpreter, where you see command prompt in DOS, where you see dollar and hash prompt in Unix operating system. And this is a Windows operating system. Goals of operating system. Primary goal is user friendly. Which is user friendly? Windows. Windows operating system is user friendly. And efficiency, it should be secure from others. Unix is the completely efficiency. And reliability and robustness. And scalability, ability to evolve. And the portability, it has to run on different platforms. Like I can able to run 4 GB of RAM. I could able to run 8 GB of RAM. So even minimized hardware, it should be able to RAM even more hardware also it should able to run. So starvation and preemption. This is another fundamental. What is this preemption? When you talk about the preemption, suspending. So when you are running a program, for example, let us say right now CPU is busy with hello.c and user is saying that pause hello.c, pause hello.c because the same user is sending this time, I want to play game. Then immediately what happened? This hello.c is suspended. Is hello.c is suspended? Then CPU becomes here it is busy. Now CPU becomes free now. CPU is free and you are able to give this to CPU. That's the meaning of preemption. Preemption concept is nothing but where user processes are and system processes are sometime in ready queue and sometime with the CPU. Sometime it is with the CPU, sometime it is with the ready state. So this is with the CPU, this is with the ready queue. This is what is the meaning of preemption, suspensions. And when you are talking about the starvation, you may not get a time. So you're standing for some resource, but you are not getting it for a long time. But preemption is not like that. Once my task is completed, I will play it once again. But starvation, nothing like that. P1 is in queue. Next process has come. P2 is in queue. Next process has come. P3 is in queue. They are all in queues. And you do not know that when are you going to chance to access CPU. Because CPU is busy with the process P10. CPU is busy with the process P10 and we do not know that when the P10 get finished. P10 have indefinite time. Indefinite time. Then in this case, these guys, whoever is standing in the queue, which queue they are all standing? They are all standing in which queue? The ready queue. They are not able to get the CPU. Then in such case, you may call it as what? Starvation. Starvation finally may leads to a concept of what? Indefinite waiting leads to a deadlock situation. They have to be killed because they do not know that when are they going to get a chance to access CPU. So that's the meaning of preemption and starvation. Preemption is nothing but temporary interruption, pause. After your task is completed, we will play it. Starvation is indefinite blocking is associated with a sometime high priority is killing with a low priority process. So high priority process is killing low priority processes. Then in such case, you may call it as a starvation. If it's a priority inversion, then high priority process is being killed by low priority processes. The functions of operating system. It has to do process management, creation of the process, termination of the process, memory sharing, and accessing the file creation, file deletion, file copying, file pasting, all the operations, device management, hard disk scanning, identifying are there any bad sectors are there or not, identifying whether disk is properly working or not, security and protection, and resource allocation, sharing the resource among the processes. And view of this is a bird eye view where you see that operating system is attached with the different hardware components, dealing with a disk, dealing with a monitor, application programs, printer, mouse, and keyboard. Don't think otherwise. Functions of operating system and components of operating system is completely different. Components of operating system is nothing but they are purely operating system inside they are available. Each component is a core to that particular operating system. Here I'm talking about purely hardware peripherals. So that's about the fundamentals of operating system.